everyone, welcome to Pepcoding. Today we are going to see about an interesting topic of kth node from the end of the linked list. That is, I am going to find the kth node from the end of the linked list. Okay, it is very easy, but there is one condition. I need to find the kth node from end of the linked list without using the size data member. Without using the size data member, I am going to find my answer. Okay, before going to solve the solution, I will tell what I have to do. First question is what we have to do. We have to find the kth node. That is, if 1, 2, 3, 4 and 5. Okay, 4 and 5. Sorry. 4 then 5. Here my head is 1, my tail is 5, size is also 5. If the case value is 2, then I have to return 3. Right? It is second element 0, 1 and 2. So it will be my answer. 3 will be my answer. I am going to return it. It is what I have to do. Now I will tell how I will do this. How? Okay. 1, 2, 3, 4, 5. We are going to take two elements. One is fast, another one is slow. I am going to maintain the k distance from the fast and slow. Okay, that is slow is equal to 0. The value is k, right? So the fast, I am going to maintain a constant distance. Okay, we are going to maintain k distance from slow to fast. Okay, we are going to maintain k distance. How we can do this? See, we are going to assign both fast and slow in the head node. Okay, if k value is 2, okay, we are going to give one condition, that is I is less than k. I starts from 0. If I is less than k, then the fast will move to the fast of next. Okay, that is, in the first iteration I value 0, it will move here, then it will be my fast. In the second year, the I value is 1 less than 2, the condition is true, it will move here, then my fast is here. Fine. If 2 is less than 2, the condition is failed. If this condition is failed, then we have to iterate another loop. In that loop, the slowest move to and slow of next, fastest move to and fast of next. Now is also the distance between the slow and the fast is 2. That is k. Okay. We are going to maintain the distance of fast to slow is the k distance. This is my approach. We can solve this. Okay. First, we are going to assign slow. Slow is equal, First, we are going to assign slow. Slow is equal to self.head. Then we are going to assign fast. Fast is equal to self.head. Fast is equal to self.head. I plus is equal to 1. That is, we are going to, first we should assign the value of I is equal to 0. Fine. Then we are going to give a condition. Then we are going to give the condition. The condition is while I less than k. Till I less than k, I plus is equal to fast is equal to fast of next. That is, it is moving to the kth value. Next. That is k distance from, yes, okay. fast is equal to fast dot next. Then I value is getting incremented by 1. I is equal to getting incremented by 1. We know that in Python there is no increment and decrement operator, so that we are using I plus is equal to 1. Fine. Then we are going to check one condition, that is while fast is not none. While fast is not none, it is, that should be a not lost element, okay, because we are going to give the first stuff, right? If it is an even linked list, then we are going to give the first end of the last, right? So cell, it should be not equal to self dot tail. If it is self, if it is not self dot tail, then slow is equal to slow of next. Slow is equal to slow dot next. Fast is equal to fast dot next. That's it. It is a very simple program. Fast is equal to fast dot next. Then we are going to return, the value of slow dot data. Fine. Okay, we completed our code. We are trying to run this. Yeah, it is accepted. Let me submit. It is submitted. Okay, it is a very easiest and simple question. I hope you all are understand the video. If you understand this video, then stay subscribed to Pepcoding. Thanks for watching.